All right, class, next section, 6.4, proving triangles similar by AA, or angle-angle similarity postulate. Not to be confused with our congruence postulates like SAS, SSS. Those things were proving triangles congruent. Now we're going to be proving triangles similar. So similar does not mean the same, but it means like it, similar to it. So we talked about in the congruence statements that we couldn't prove triangles congruent by angles alone because the sides could be different lengths. Well, similarity, that's fine. They're similar shapes, just different sizes. So the angles will all be the same, and then the sides will be proportional. So we'll look at that. So angle-angle similarity postulate is if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So using this example, we want to use the AA similarity postulate to determine whether the triangles are similar. If they are, we'll write a similarity statement and explain our reasoning. So remember, to be able to prove them similar, we need to be able to prove two sets of angles congruent. We have one set, B and E are both right angles, so we know they're both 90 degrees. Angle B is congruent to angle E. That's one of them. They all equal 90. But our other two angles are 38 and 52. But they're in separate triangles. So what we need to do to find out, we need to find out what those missing angles are. If A happens to be 52 also, then we know it's congruent with D. If F happens to be 38, we know it's congruent with C. And we would have similar triangles because the angles would be congruent. So to do that, we have to use our triangle sum theorem. Because we know all three angles of a triangle add up to 180, we can take the two that we know and subtract them from 180 to find the one that we don't know. So if I look at my triangle on the left, I would take 90 plus 38 plus angle A, which is what we're trying to find out, equals 180. And then subtract 90, subtract 38, which is 128. So we'll subtract that. And do we get 52? We will. So angle A equals 52, which is the same as angle D. So I know angle D and angle A are congruent. And we also know our right angles are congruent. So we have our two angles that are congruent. So we need to write a similarity statement. We're able to show that they're congruent. Now we need to write a similarity statement. So if I call my first triangle ABC, that would be similar to triangle, D matches up with A, and E matches up with B, F matches up with C. So that would be my similarity statement. And then explain our reasoning. The triangles are similar due to AA. Due to the angle-angle postulate. All right, our second example, we want to show that the triangles are similar. We have our two triangles TUV and HJK. We can see that they both have 115 degree angles. So those two angles are congruent. And we can see that each of them have two of their sides marked as congruent, but that's TU is congruent with TV on the same triangle. So that means they're isosceles triangles. So even though TU is shorter, and just by looking at it, it looks shorter, right, than HJ, we still know that TUV is an isosceles triangle. So these are isosceles, meaning two sides are the same. And if we remember back to Unit 4, with isosceles triangles, anytime we had an isosceles triangle, we knew the base angles were congruent with one another. So we know that angle U is congruent to angle V, and angle J is congruent to angle K. And since we know what T is, we can subtract that from 180. So 180 minus 115 and that gives us 65. So my two base angles add up to 65. We only took one angle away, that 115, so what's left is both of them put together. So I need to divide by 2. And that gives me 32.5. So each of those angles, angle U, angle V, angle J, angle K, are 32.5 degrees. Each of them, 32.5 degrees. So because we have two pairs of congruent angles, the triangles are congruent by AA. The triangles, sorry, are similar. I think I said congruent. Triangles are similar by AA. So our similarity statement could be TUV is similar to HJK. And maybe just add in that little similar sign there. We know that they're similar now. And those letters do match up. They do correspond with those vertices. All right, our second example, we have triangle LMN. That's our large triangle here. And we have a smaller triangle, PQN. What we're shown is that those two lines there are parallel. So in our previous unit, our parallel lines showed us some alternate interior angles. This example here specifically doesn't show us alternate interior. It shows us some corresponding angles. So remember our corresponding angles, we had our parallel lines and the transversal would be like 1 and 2. They're in the same position, one on the same position on the inside, one on the same position on the outside, or vice versa. So if you think of that quadrant on the top and the quadrant on the bottom, the 1 and the 2 are in the same spot, that bottom left spot. Or it could be the bottom right spot, or the top left spot, or the top right spot. But it will match up the corresponding position. So that's what we have in this triangle. We have angle M and angle Q are congruent because they're corresponding. And we know angle M or angle L and angle P are congruent because they're corresponding. So corresponding angles. So maybe off to the side we can say all of that information that we know. So we know that angle L and P are congruent. By corresponding angles. We know M and Q are congruent by corresponding angles. Now we have two sets. That's all we need. But say you didn't recognize the corresponding angles first. Maybe you looked at the third set of angles, because we can show that they're congruent also. Angle N is congruent to itself. They both have the same angle, they share that same angle. So in our previous unit, we dealt a lot with reflexive sides or shared sides. This is a shared angle, so it is the reflexive property. So angle N is congruent to angle N by the reflexive property. And we only need two of the three. We only need to show two of the three. So our triangles are similar by angle. And so our letters up there do match up in the right spot, so we could even just change that and to a similar. We know that they're similar now. And that could be our similarity statement. All right, let's determine whether these triangles are similar. And if they are, we'll write a similarity statement. So looking at the first one, we have our two right angles. We know that those angles are congruent. We just need one other set of angles. We don't have any parallel lines, but we do have our vertical angles. Remember vertical angles, they'll still be a thing. Still got to identify those vertical angles. So yes, triangles are similar. And our similarity statement could be, if I call my first triangle CDE, it would be similar to triangle GFE. On number 2, we see that we have one set of angles, our right angles, M and Q, are congruent because they're both right angles. So this is another one like our first example where we need to use our triangle sum theorem, add up our known angles, subtract them from 180, and see if they match up with the missing angle. See if our missing angles match up. So if I look at my top triangle up here, and I do 90 plus 71 plus angle P equals 180. See, 90 and 71 is 161. And I can subtract that from 180. Angle P equals 19. So that is congruent with angle L. So we've got our two sets of angles that are congruent. So yes, triangles are similar. And our similarity statement, if I name my first one PQR, PQR is similar to LMN. Number 3, we can see that S and J are congruent. They're both 28. So we need to find out, just like we did with number 2, if our missing angles match up also. So 72 plus 28 plus angle T, set it equal to 180. 72 plus 28 is 100. So 180 minus 100 is 80. Angle T equals 80. $80 does not match up with angle K. So no, our triangles are not similar. Number 4, we have parallel lines. We know our vertical angles. But with our parallel lines, in this type of triangle setup, we will have alternate interior angles. So we've got an alternate interior angle here at Y and Q, and also one at P and X. So either way, I could look at just my alternate interior angles and get my 2 angles necessary, or I could look at my vertical angles and then one of my alternate interior angles, and I'd have all the angles necessary to prove my triangle similar. So yes, triangles are similar. And a similarity statement could be, if I call my first triangle X, Y, Z, it would be similar to triangle PQZ. Right, one more example. So let me scroll down. There we go. All right. We need to use indirect measurement. So shadows, we have these shadows, okay? A building casts a shadow that is 78 feet long. At the same time, a nearby signpost that is 5 feet tall casts a shadow that is 39 inches long. And we can figure out how tall the building is. So the building and the signpost form sides of 2 right angles with the ground, as we can see in our diagram. And the sun's rays hit the building and the signpost at the same angle. So we have 2 pairs of congruent angles, so the triangles are similar by the angle-angle similarity. So we can use that to find our, so now that we know that they're similar, we can use our proportions and find our missing height of the building, X. So we do need to notice that our units are different. That's important. So let's make a note of that. We know our units are different. We've got inches and feet. So we need a conversion. So 39 inches times 1 foot over 12 inches. Gives us 39 over 12. So inches cancel out there. We're converting 2 feet to get into feet. And that simplifies, or put into decimal form, is 3.25, or 3 1/4. 3 1/4 feet. So that is, that gets our inches out of the way. Scroll back up just a little bit, not that much. Okay, We'll just have to deal with what we got. All right, so now that we made that conversion, we can set up our proportions. To do that, we match up x, looking at our building side of x, it corresponds with our height of our signpost, which was 5 feet. And that proportion is going to be equal to the length of the shadow on the building, 78 feet, over the length of the shadow of the signpost, 3.25. Remember when we did our proportions? They have to be equal if we know the triangles are similar. So then we can just cross multiply. And we have 3.25x equals 78 times 5 gives us 390. And then we need to divide 390 by 3.25. And x equals 120 feet. Don't forget the unit of measure. Don't forget your unit of measure. All right, that is it on the notes. Work on the 6.4 homework.